We have discussed control sources using the transistor as well as using the op-amp, and those of you who have been observing carefully will probably realize that there was some cheating involved here. That is, using the transistor, I did realize all four kinds of control sources: voltage controlled voltage source, voltage controlled current source, current controlled current source, and a current controlled voltage source. But voltage controlled voltage source had a gain of 1. Okay, I didn't realize V0 equals K times Vi, where K is something other than 1. And similarly, the current controlled current source had a gain of 1. Okay, I didn't realize I0 equals K times II, where K is something more than 1. And in case of the op-amp, I discussed only the voltage controlled voltage source and the current controlled voltage source. Of course, the voltage controlled voltage source had a gain that could be anything. Okay, K can be greater than 1 in this case. Now, why did I limit myself to these, and why did I constrain myself to a gain of 1 for the voltage controlled voltage source and the current controlled current source? The point is, let's say if we had a controlled source like this, that is a basic control source which was like this. If there is some Vx, this gives me some Gm times Vx. Or alternatively, I could have a voltage controlled current source. If this is Vx, I could get some A0 times Vx. Now, using these, I could build any other kind of negative feedback controlled current sources. Okay. So essentially, using these, any controlled source can be built using negative feedback, and it will have all the good stuff. If this Gm becomes very large, the transfer ratio of the control source becomes insensitive to the exact value of Gm. Gm could vary by a factor of 10, but the transfer ratio doesn't change much. Similarly, A0 has to be very large, but it doesn't matter whether it's 10,000 or 100,000. Even for a factor of 10 change, the transfer ratio doesn't change very much. So all control sources can be realized, and you will not even have the restriction of unity gain. Okay, any control source also with any gain, it can be realized. Okay, now what is it that we do have? We have a MOS transistor, which is a voltage controlled current source, and it looks like this. VGS, Gm, VGS. Okay. Now, what is the difference? The obvious difference you see is that here the controlling nodes are completely separate from the controlled nodes. Okay. Whereas here, one of the controlling nodes and one of the control nodes is common. It's the source of the transistor. Okay. This is the reason why we can't make voltage controlled voltage source or voltage controlled current source with gain more than 1. Okay, because it's already tied here, right? So these two have unity gain. Okay, so with this anything can be made, but it's almost like we are given this control source, but with these two tied permanently together. Okay, so we can't break that. Of course, it's part of the transistor, so we can't realize gain more than 1. And the op-amp, while it's a voltage controlled voltage source, is also not like this. Okay, it's not like this one here. Okay, so what we have is this, and this is separate from the control side, but on the control side, one side is implicitly grounded. This will be the common reference node in the circuit. So you can't lift this terminal off the ground, it's part of the op-amp. And we have only this terminal that is free. And this is why we can't realize the current sources, either the current controlled current source or the voltage controlled current source. We can't do this Because when you realize a current source, you need two terminals. That is, let's say you provide the current output from there. To sense the current output, you need the other terminal, because some current is flowing from here to there. You sense it at this terminal and you provide the current output at that terminal. Both terminals have to be free for a current output device. Okay, like a current controlled current source or a voltage controlled current source. Now, because we don't have access to both terminals, we can't obtain a current output from an op-amp. Okay, so this is why essentially I led the discussion to whatever we can realize. Now, how would we go about realizing gains more than one using MOS circuits? MOS voltage controlled voltage source or a current controlled current source with K greater than 1. Can we do this? Please think about it. Maybe pause the lecture and think about it. Now, it turns out that knowing what we do now, we can still do this. One easy way to do it is you have a MOS voltage controlled current source and follow that with a MOS current controlled voltage source. Okay, I will show it schematically like this. If this is Vi, I'll get something here which is IO1, and I'll get something there which is VO, and IO1 will be some GM times Vi, and VO will be some RM prime times IO1. Together we'll get a gain of GM times RM prime, which can very much be set to greater than 1. And if you want to realize a current controlled current source, you simply reverse the order of cascading. Okay, you first have a current controlled voltage source, and after that a voltage controlled current source. If you have an input current, you will get VO1 from that, and you will get IO from there. And again, the gain can be adjusted to be more than 1. Now, this is possible. It is very much possible to realize gains more than 1 for a voltage controlled voltage source or a current controlled current source using only MOS transistors. But one thing here is that there are two separate feedback networks, one to realize this stage and another one to realize that stage. Okay. Now, it turns out that you can also do these things using MOS transistors with a single feedback circuit. Again, these are not things I'm going into in great detail, but I'll just suggest it, and as an exercise you can try to do it yourselves. It's actually quite fun. Okay, in fact I would encourage you to use either of these current sources and synthesize all 4 kinds of control sources using negative feedback. Okay, it is similar to what we did for the cases earlier, that is 4 control sources with the MOS transistor and the 2 with the op-amp. But now if you do have all 4 terminals free, you can realize everything. Okay, so you can try to do that. Now, how can we do that in practice? One possibility is to not just use single transistor. Everything we tried so far is with 2 transistors. So again, I'll show schematically the picture. I'm not going to show biasing and so on. So let's say this is the input. You have to replace the incremental equivalent and carry out the analysis and so on. And these two are the outputs. Okay, this is in plus and in minus, and this is out plus and out minus. So we do have 4 distinct terminals, 2 terminals for the input and 2 terminals for the output. Of course, you first synthesize the signal picture using this and add biasing to get the complete circuit. This is still not exactly equivalent to this one. Okay, because in this case no current flows into this or that terminal, whereas in this case no current flows into that one, but some current does flow into that one. So it's not exactly equivalent, but you can still work with this. And another combination which will let you make all 4 control sources is to combine an op-amp with a transistor. Okay, so you have the 2 input terminals over there and 2 distinct output terminals over there. Whatever current goes in here comes out there, so you can sense the current as well as provide it to some other circuit. And using this you can realize all 4 kinds of sources, and this is roughly equivalent to that one. Okay. So in fact, I would encourage you to try this out, try to synthesize these things, and it will actually help you a great deal in your understanding of circuits. Okay. So with this, you can in fact synthesize all 4 kinds of control sources with no restriction on gain. Okay.